More than a year ago, I posted a video about how UniFi's ad blocking and content filtering work. Since then, Ubiquiti has changed the implementation for content filtering. So this video is to understand how content filtering works now. Before talking about content filter, let's first investigate when the content filter is disabled, how the DNS name resolving works in UniFi system. In the UniFi network application, under settings for networks, I have 3 VLANs. And for each VLAN, I have the same DNS setting, which is author. Author means each VLAN will use the gateway as the DNS server. Then for internet settings, for the primary one part, you can see for DNS server, I set it to 9999. All the DNS name resolving will end up with 9999. Let's see how the DNS name resolving packets work inside the gateway. In the lower left, I have a Wireshark. Let me start capturing. I use the SSH remote capture. I connect to the UDM Pro, and under capture for interface, I say any, because DNS packet will be transferred within the gateway among multiple interfaces multiple times. So I want to see the exact packet transferring. So I set the remote interface to any. Then for filter, I'm only interested in DNS, so I filter it to port 53. Okay, start capturing. Then in the lower right, a Linux machine. Let me try to dig a Google domain name, which is adservice.google.com. You may know this domain name is supposed to be blocked if you enable ad blocking. But because now I don't have the content filter enabled, let's see how it works. In the left, a lot of DNS activities are going on, but they have nothing to do with what I'm going to test in the right. So now let me write in the right. Okay, in the left, multiple packets were captured. Stop capturing. Let's start from the very first one, this packet. See, the source IP address is this one in VLAN 66. We can validate in the right side. It's the exact same IP address of the right side Linux. It sends the DNS request to the gateway. Why? Because in network configuration in UniFi network application for VLAN 66, I set the DNS server to author. Author means gateway. So this packet makes sense. Then the next one, it seems the source and the destination are exactly the same, right? But if you check the interface index, you will see the different interface number. So now we need to understand what these numbers mean. I need to SSH to the UDM Pro. So in the lower right window, let me SSH. Let me run IP link. In this output, we can see what are the interface indexes. For the first packet, index 23, which is this interface, it is the VLAN 66 interface for the LAN part. And then the next one, index 31, which is this one, bridge for VLAN 66. Let's see. The third packet is sourced from the one part IP address of this UDM Pro. Destination is 9999. So let's first check what's the index 3. Index 3 is Ethernet 9, which is my primary one part. It makes sense, right? Because the gateway need to send the real request to the real DNS server. Why the DNS server is 9999? Because in UniFi gateway for primary one part, we set it so, right? So all the 3 packets make sense. Then move on. The next 3 packets are just return packets from the 9999 back to the Linux server. If we dig deeper into the first packet, which is from the Linux to the gateway, if we check the destination port number, you can see it's 53. That means something's running inside the gateway, which is listening on the port 53 so that the first packet can be successful. Right? To understand what process is listening on 53, in the right side SSH, let me run netstat. I want to see the processes listening on 53. Okay, a lot of lines. Let's focus on the UDP. You can see there are processes listening on all these 4 different IP addresses. And what are the process? DNSMasq. In fact, inside the UniFi gateway, DNSMasq is used to support DHCP and DNS name resolving. Now let's look into how DNSMasq works inside the UniFi gateway. In the left side SSH session, show you all the DNSMasq processes running now. You can see there are multiple DNSMasqs running. From the parameters, you can see one is using a configuration file called main.config. The other one is running using a different configuration file, ethernet9.config. For this UDM Pro, Ethernet 9 is the primary one part. And in the right side, let me run netstat and show you all the DNSMasqs which are listening on a part. They belong to two groups. One is listening on port 53, which is expected, right? The other one listening on this strange part, 20201. Then if we look into the two different configurations, for example, this Ethernet 9, let me copy the configuration file path, show the content in the right side. So you can see this is a regular DNSMasq configuration, but at the end, you can see it's not listening on the regular port 53. Instead, it's 20201. In fact, this part is not used in this video at all, but let's still use several minutes to look into IP tables. Let me first show the Mango table in IP tables. You may know Mango table is used to mark a packet for various purposes for later uses, for example, firewall. IP tables and only show the Mango table. You can see for this particular chain, if it's UDP, it will check whether the destination port number, whether it's domain means port 53. If yes, it will furtherly check whether the destination IP address is local. Local means the local IP addresses for the UDM Pro. For example, for this VLAN 66, the local IP address is 192.168.66.1. So if the destination IP address is local, in my case, it's true because in my VLAN 66, I set the DNS server to alter. Alter means I will use gateway as DNS server, right? So basically for my particular case, this condition is met. That means it will return. It will not continue. But what if I use external DNS server, for example, Google? So then the flow will continue. I only have the primary one part active, so this condition will be fulfilled. The end result is my packet will be set with this mark 1A0000. So this is for this particular chain, right? If the packet directly comes from one part, you can see the system will directly give the packet this mark 1A0000, the same as this one, but in different situation. Okay, I copied the important part in the upper side slides as well, just for later reference. So this is the Mango table. Then let me show you the NAT table. That's where the DNS hijacking happens. Okay, this is the NAT table. If I scroll to the end, you can see this interesting part. This is part of the pre-routing. If a packet has this mark, this is familiar, right? In Mango table, we saw it twice. If the packet has this mark, and if the destination IP address is local, meaning the UDM Pro, the system will redirect the DNS request to this part. That's where the hijacking happens. But in our case, this redirect will never happen. The reason is our packet will never get this mark. This is the NAT table, right? If we refer to the slide for the Mango table, you can see for our packet, because our destination type is local, it will directly return. The packet will not get this mark at all. Then go back to this NAT rule. Even though our DNS testing fulfills this condition, it doesn't meet this condition. That means this redirection will not happen. Our packet still has the port 53. Let me show you the DNSMasq processes again. Here you can see for the different DNSMasq processes, we can find the process ID here, right? Then in the right side, let me show the processes which are listening on port 53. You can see the process ID ends with 500. Go back to the left, it's this one. And you can see this DNSMasq use this configuration file. So in this way, we can continue looking to see how the DNSMasq is configured to support the DNS query in this testing. Let's show this main.config file in the right side. There's nothing strange here, simply configured listening on multiple interfaces, including the WireGuard VPN interface. Then at the end, you don't see the port setting, which means by default is listening on port 53. And another thing is, see here, for the configured interfaces, you don't see LO, the loopback interface. However, in the left side, we can see we do have DNSMasq, the same 500 process listening on the LO interface. Why is that? In fact, even though we don't configure the loopback interface in the configuration file, DNSMasq will still bind to the loopback interface. We checked the main config file, right? If you check the DNSMasq command line, you can see it not only specifies the configuration file, but also configure a resolve file. This resolve file will determine which ultimate DNS server will be used. Let me show you what I mean. Let me copy this main resolve file. Then in the right side, let me display it. It's very simple. It simply says name server 9999. Why this IP address? Because in our primary one port configuration for DNS server, I customize it to use 9999. Because of these two configuration files, the DNSMasq knows how to serve our LAN DNS query and how to forward to the external DNS name resolver. Okay, we are good with the default situation, which is we don't have content filter enabled yet. Now let's go to the real topic for this video. What if you enable content filter? How the system reacts. In UniFi network application for settings, cyber secure, if you go to content filter tab, if you create new, you have several main options. You can enable ad block. Then you can customize the safe search for search engines. You can configure the filtering. If you don't pay any extra, you have the basic option. If you do pay, then you have many categories to choose from. So in this video, we will cover all of them. I already configured 2 filterings for 2 of the VLANs. Let me enable them. Okay, they are enabled. For VLAN 66 first, I enabled ad blocking, I enabled safe search, then I turned off the filtering. Okay, then for VLAN 88, I have the ad block disabled. I do enable the basic filtering. So these are the simple settings for now. Later you will understand why for one I only have ad blocking enabled, for the other one I only have basic enabled. Later you will see. Let's investigate how the content filter even works. Everything you configured here, technically they need to apply to DNS queries, right? But if your DNS queries are simply forwarded by DNSMasq to external DNS queries, whatever you set here won't be effective, right? So the system must have a way to hijack your DNS queries and then internally do something. If everything's okay, the system will forward. Otherwise, it will take action, right? Let's see whether it's the case. Even though it sounds counterintuitive, to be honest, the easiest way to understand how it works is to start with IP tables. So in the left side, let me show you the Mango table. Immediately, I see some big differences. See here, it has a new chain. It's called DNS filter jump. And see what it does. For example, in our case, for DNS query, it's UDP, right? It will do what? It will check whether the destination port is 53, yes, and whether the destination address is not local. See this exclamation. This means the destination is not local. Then the system will do this, will set this value, 760000, which means if you want to bypass the gateway. If you want to directly use external DNS servers in your client, the system will still catch it. The system will mark the packet with this number. Let's see here in this chain, if you do not use the external DNS server, you still use the gateway as DNS server, so your destination address is local, then the system will simply return, will not mark your packet with a special value. Okay, depending on what type of DNS server you use from the client side, the system will mark your packet differently. Now let's move on to net table. This time it's interesting. See this part for DNS filter chain. If your packet is UDP and if your source IP address is within this IP set in a separate SSH session, let me show you the content of this IP set DNS filter. See, it simply includes these two subnets. Why these two subnets? In my network configuration, you can see I have totally 3 VLANs. Why in this IP set only 2 subnets are included? Because for content filter setting, I only enabled the content filtering for these 2 VLANs. That's why here I only see these 2 subnets. Then go back to the net rule. So we meet this condition, then of course our DNS query meet this condition as well. Then see what the system will do. Keep in mind this rule is DNet, so the system will translate the destination address, so which means no matter whether you use gateway as your DNS server or you use external servers, for example 8888, it doesn't matter. The system do a DNet and hijack your query to this local IP address and this port number. That's how the content filter can be effective. The system needs to first hijack your DNS query to this address. Now let's continue. Let's see what process is listening on this strange 1053 port number. Let me see what processes are listening on this port. So we only have one process, it's CoreDNS, the hero for this video. Then in the right side, let me see what's the command line used to run CoreDNS. From this command line, we can know the configuration file. Then in the left side, let me show this configuration file. What you are seeing now is called core file. So basically it's the configuration file to run CoreDNS. Here I'm showing the CoreDNS GitHub page. It is an open source tool. Here you can see the short introduction. It is a fast and flexible DNS server. The keyword here is flexible. Why so flexible? Because it uses the plug-in architecture. So whatever you see in UniFi's content filtering, each of them is implemented by a plug-in. Then let's read the core file. See here, the first line, it specifies the port number, right? And it binds to the loopback interface and it supports statistics. In fact, whatever you see within the curly brackets, each section is for one distinct plugin. So in right side, let me show you the CoreDNS version. Then let me list the current available plugins in UDN Pro. For example, the bind, yes, it's a plugin. Statistics, yes, it's plugin, right? They are simple to understand. We will skip them. And for this cache, later in this video, I will talk about it. In fact, this is a major problem for CoreDNS or for Ubiquiti's implementation, because for different content filtering rules, DNS query results may be polluted by other content filtering rules. Later you will know what I'm talking about. But for now, let's skip the cache. Then see here, there's a plugin router. So this is an important one because CoreDNS use this plugin to decide how to run other plugins. That's the so-called router means here. See here, it has different rules. The first rule for this 66 subnet, it will run multiple nodes. The first node, cache, then host set, then safe search. here comes another rule, which is for VLAN 88, and the third rule applies to all subnets. And for some of the nodes, for example this one, you can see a colon followed by a number, right? So basically this means different instances of the same node type. For example, for the host set, you see here, this is the plugin host set. I have two nodes. The first node is 0, and it is used for VLAN 66. And the second node has the number 1. It is used for VLAN 88. So in this way, the CoreDNS can specify different instances of the same node type to support different customizings. That's why in UniFi network, we can have multiple content filtering rules. They can be implemented by using different node instances. Then let's try to understand the host set. Let's think about UniFi's content filter from the user experience perspective. So I'm a user. I launch a browser, type in a domain name, which I'm not supposed to access. It should be blocked. So then the system will do what? The system need to decide whether the domain name is allowed or not. If it is not allowed, the system will display a special page giving me a feedback. Okay, you are visiting a page which you are not allowed to access, right? Everything I just mentioned need to be somehow configured in this host set setting. So let's see how it's done. For the first one, the node 0 for VLAN 66. How we configure the VLAN 66 in UniFi? We say we enable ad blocking. We enable safe search. Then I do specify a domain name for block list. So let's see how this are implemented. See the first one, exclude domain files. In right side, I already show you the content of the file. It simply specifies some domain names. No matter what, the system need to enable them. For example, the first one is used by Mac machine to see whether your network can access internet or not. And for example, UniFi is used by your UniFi device to connect to the controller. They are crucial domain names. They shouldn't be impacted by whatever you customize. So that's why all of them are included in this exclude domain files. There's another one is for include domain file. Let's see what's inside this list. This file only includes one domain name. Why this one? Because in UniFi network settings, I specifically add it to the block list. I know it's a little bit confusing. I added to block list, but in the CoreDNS setting, it's in include domain files. This makes sense if you think about it. From CoreDNS perspective, for host set, if you say include, that means you want to block it. That's why the block list domain name is included in the include files. I hope it's clear. So then let's move on. See this one, block address v4. See this strange IP address. Even though this IP address looks like public internet IP address, but in fact it is not. It is in the special range and they are reserved for special use. For example, for internal documentation purpose. So Ubiquiti chooses this particular IP address as the block address. So you can see the effect of this IP address if you want. You can even try to type in this IP address in a browser. You will see this page. This is the exact same page you will see if your domain name is blocked by content filtering. For the system to return such page, there must be a web server running to support this IP address, right? In fact, even just to show that block page, it's not very easy because the system need to use net. So let me show you the net table. See this block page jump chain? They are DNet rules. For example, the first one is for HTTP. The second one is for HTTPS. They are similar as long as whatever process they want to access this destination IP address, and if it's HTTP, it will be redirected to this local IP address and this port number if it's HTTPS to a different port number. So this is DNet rule, which guarantees if you want to display the blog page, something listening on these two ports should serve the page, right? So then let me show what processes are listening on those two ports. Let me use 2080 as example. I use netstat. Okay, we got the answer. The UniFi gateway doesn't use the traditional engines to serve this simple blog page. Instead, it uses a very lightweight web server, which is called Light HTTPD, to serve that single blog page. I hope it's clear about the blog address part. Let's move on to this one. This one is the reason why most people even want to look into the content filtering in UniFi Gateway. It can do the filtering to implement the different categories. The system uses some internal data on file system level. They are already pre-grouped into different categories. Let me show you. In the right side SSH, let me cd to ETS UTM. In this folder, Ubiquiti stores the files for the domain name and the categories in this folder, pre-calculated list. So if I cd to it, you can see there are totally 27 CSV files for now. Let me open a random one, for example, the 21. You can see for each file, it's the same structure, 3 columns: category, host, which is the domain name itself, and the type, which is always domain. What you see now, they are all advertisement related domain names. Apparently, they are supposed to be blocked if you enable the ad blocking. But because there are so many files and each file is huge, I really want to know what are the available categories and the count. That's why I programmed this very simple Python script to do the legwork for me. It will count all the categories in all the 27 files. Okay, so let me write. See, there are dozens of categories. Most of them are not big at all. The biggest one is advertisement. You can see the count here. Another tricky part is I do not see a category named as family. So the reason I'm trying to look for family is in the past, Ubiquiti simply used clean browsing service to do the content filtering. For example, for family, there is a particular DNS server to filter out adult contents. There's another dedicated DNS server. That's how it worked before. But now, because Ubiquiti has already changed the implementation to use CoreDNS, but the settings on the UI are very similar. Here, it still has a family option for filtering, and if you check the CoreDNS configuration file, you can even see for VLAN 88, the category is called family, right? However, I don't see any category called family here. So my theory is internally, the family category is mapped to multiple existing categories. For example, adult, for example, something else, right? I don't have time to try them one by one, but at least that's how I think the way it works for family. That's not important because for this video, we can simply use advertisement to continue our investigation. By the way, under the etc UTM folder, there is a category codes CSV file. If I show you the file, you can see the same categories which I derived by running my own Python code, right? Similarly, I don't see family. Okay, so now we know where the database is located. So by using that, the system or the CoreDNS process knows which domain name is advertisement, which domain name is for adult. Then let's move on about this configuration file. You can see next one is syslog. This simply means whatever is blocked, a syslog will be generated. Let me go to the syslog folder, var log ulog. You can see this file, content filtering log. If I tail the file, you can see some existing blocking already, right? Let me start clean. Then in the left side, let me use a test Linux machine, which is in VLAN 66. Remember, for VLAN 66, we enabled ad blocking, right? Let me try to dig adservice.google.com. You can see the dig result is successful. However, the IP address returned is not really the IP address for the domain name. In fact, it's our block IP address, right? And in the right side, you can see the syslog. So that means the ad blocking works for VLAN 66. You already see it work in action. Then go back to the CoreDNS configuration file. So we just finished this host set, which is for VLAN 66, right? In the exact same way, there's another configuration for different node 1. This one is for VLAN 88. They work in the similar way. Then move on. Next two nodes, they are for safe search. So see, for VLAN 66, for safe search, I enabled Google and Bing, right? See the configuration, Google, Bing. And for VLAN 88, I enabled YouTube. See this? Yes, YouTube. Exactly as what we specified. And the real implementation is done by the plugin, which is called Safe Search. In this video, I'm not going to demo how the Safe Search works. It's very simple. Then the very last thing in the configuration file I want to mention is this plugin, Forward. And if you scroll to the beginning of the configuration, you can see the forward is called in the third rule. The third rule applies to all the subnets, which means for VLAN 66 and 88, they are both required to execute this rule. So at the end of this rule, it will do the forward. Forward to what? Local IP address. Can you imagine what happened after the forward? It's related to what we already discussed in the very beginning of this video, which is the regular DNSMasq situation. Because DNSMasq is listening on the local IP address, this part, right? If CoreDNS forward the query to the DNSMasq, DNSMasq will continue and forward the query to whatever DNS server you specified, right? Now you may understand CoreDNS doesn't really do the recursive name resolving. No, it simply runs multiple plugins to see whether it should block the page. If it doesn't block the domain, CoreDNS tool itself doesn't have the ability to resolve the domain name. It has to forward your query furtherly. That's what the existing process for inside your UDM Pro. The DNSMasq will relay the query to the real DNS server. Okay, we are done with the CoreDNS configuration investigation. In my current content filter configuration, for VLAN 66, I only block S. For VLAN 88, I only block basic. So which means if now from VLAN 88, if I dig at service.google.com, it should be successful. Let's see. Yes, it is. It got result back, right? Now in VLAN 66, I do the same thing. It should be blocked, right? Let's see. Something weird, right? The S blocking is not working. I got the correct IP addresses back. If I try again, still successful. But you can notice this number is getting smaller and smaller. This is the TTL. This is the seconds left for this cache to expire. So let me keep trying. Okay, 5 seconds left, 3 seconds, 1 second. Okay, see, after it expires, see, what's the result? This result is the correct result. It's what we expect, right? Then what's going on? Why it didn't work? This is related to how the cache is set up in UniFi Gateway's CoreDNS. In the right side SSH, let me show you the CoreDNS configuration file again. See here, this is the cache configuration, and we only have one cache node. And you can see for the first two rules, for VLAN 66 and 88, they are sharing the same cache node. They don't have their distinct node instance for cache. And to make it worse, this cache node is the very first node in the whole chain. Only if the cache is not hit, the system will move on to try the real blocking operation by using host set, right? But if the cache returns result already, the system doesn't bother to really try it, right? Which means if the cache has the wrong entry, your whole result is screwed. That's exactly what happened. So depending on the timing, you may or may not get the result you want, which is a very, very bad situation. Especially the purpose for this content filtering is to consistently block some domain names, right? Apparently now it's not working as expected. So we can go back to the two Linux machines, do the testing in another way. The test I just did was to start from VLAN 88, right? So now, because this adservice.google.com, the TTL is very big. So I need to wait for an hour to try again, right? I don't want to wait. Go to the database folder, etc, utm, pre something, okay? Then remember the file 021 has many advertisement domain name, right? Let me show it. So let me pick a random one. For example, the very first one. Then in the left, let me dig it. Dig. It's blocked, right? However, if I move to the VLAN 88 machine, do the exact same thing. This is VLAN 88. According to my setting in UniFi network, it shouldn't block the S, right? Then let me see. It's blocked. It returned this special IP address, and you can notice the TTL is slightly smaller than the left one. No matter how hard I try in VLAN 88, within 1 hour, I won't get this IP address resolved. Why? Because the CoreDNS process for VLAN 88 uses the exact same cache as VLAN 66. And this domain name was already blocked in VLAN 66, and the entry is still active. It's not expired yet. That's why the same dig command failed in VLAN 88 as well. This is a very bad situation. Then before ending this video, I just want to show you the issue I just talked about. It's not really related. Okay, I don't have subscription, so if I pay extra, if I switch on the enhanced, the issue will be gone, right? No, it won't be gone. It will have the exact same result. Let me show you my another environment. We can use the paid version to do similar testing. In this new lab environment, you can see I have two active content filtering rules configured. And let's say for the first one, for VLAN 100, you can see I do have the purchased subscription, so that for enhanced, I have many options, right? For this example, for VLAN 100, I only selected AI just for testing purpose. Then for the second rule, I only selected technology. Now I have two active content filtering rules, right? I need to pick some example domain names to test with. So in the upper left SSH session, let me search artificial intelligence in this database folder. Okay, search. So let me pick this one, api.chatgpt.com as an example. In the VLAN 200 Linux machine, let me dig this example domain name. Based on our customizing in UniFi network application, for VLAN 200, I should be able to access AI, right? So then let me see whether it's true. Yes, it's successful, right? Then immediately see this TTL is 300 seconds, right? So within 300 seconds, let me go to the left side of VLAN 100 machine, dig the exact same domain name. It is not supposed to be successful because in VLAN 100, I do have AI blocked, right? But let's see, it's not right. But if I try other domain name, for example, this one, www.chatgpt.com, because I haven't tried in the right side of VLAN 200, right? So then if I first try it in the left side of VLAN 100, it should work, even though we know there's a bug. Let me try. Correct. See, this special IP address is returned and the TTL is 1 hour, right? But within 1 hour, if I go to the right side VLAN, run the exact same command, because in VLAN 200, I don't have AI blocked, right? I'm supposed to get IP address back, right? Let's see. It failed. I got this block IP address and I see this close to 1 hour TTL. Why? Because CoreDNS simply get the cached entry. Okay, so after this back and forth testings, I believe it's clear about what the issue is. Okay, This ends the video. Thanks for watching.